Hi, everyone. Thank you for joining us today in this session. In today's event, we're going to discuss the topic of overcoming software supply chain risk and also talk about mitigation strategies. So my name is Alejandra Artiguez. I'm a principal security solutions architect at Amazon Web Services, and I have been invited today as the moderator. In today's session, we will share some real cases and also talk about identifying risk and mitigation strategies throughout the software development processes and environment, and also learn how you can meet the internal and external requirements while also protecting your software from these supply chain attacks. So let's get started. We'll be leaving plenty of time for questions. So if you have any question or comment, please put those in the Q&A tab. So for the question, please add those in the Q&A tab, because it's easier for us to review those and address them instead of in the chat. So allow me to introduce the speakers that we have for today. First, we have Laurence Crowther, who is the head of solutions engineering for APJS at SNCC. And we also have Steven Singham, who is the group CISO at the Catalyst and also and Bank Jago. Hi, Laurence and Steven. Do you want to add something else for your introduction?
Hola, Ali. How are you? Good to be here, everyone.
Excited.
Yeah, thanks for having me. Just a bit about myself. I've got sort of 20-year plus history in lots of different companies, mainly doing software development, more recently application security. Been at SNCC about a year. Before that, I was at a company called Elastic, and before that, Pivotal Software. And I've done many projects, I guess, on the industry side and also the vendor side. So I've got a good mix of being in the trenches and working on the vendors as well. Happy to be here.
Yeah, thank you. That is going to be, your experience is going to be very useful for today's topic. Steven, do you want to also introduce yourself a little bit?
Yeah, thank you, Ellie, and team, thanks for having me. Yeah, my background is close to 20 years in security, mostly starting at IBM and then to Salesforce, Fox Studios. And my major focus, obviously, is application security on the encryption side and privacy side. And I've been CISO for large banks and a small fintech startup the last 6-7 years.
Exciting. Awesome. Yeah, we have great speakers today. So we can start maybe with Laurence. Laurence, if you can please provide us with an overview of what is actually supply chain security. Why do you think it's so important? What are the trends that you see, the threats, and maybe some best practices? I'm sure we can dive deeper later during the panel discussion, but maybe some high-level information to start.
Yeah, for sure. It's such an interesting topic and a hot topic because of recent attacks, and it's been in the media a lot. And of course, obviously, we're going through the pandemic. Industries have changed, shifting to digital and digital channels, but sort of accompanying this shift, there's been an increase in online fraud and cybersecurity attacks. And we're seeing attacks across all industries, whether that be banks, manufacturing, insurance, high tech even as well. We're seeing high profile attacks almost on a daily basis. So this stuff is real, and we need to talk about it as an industry. Before the supply chain or dealing with third parties, it was someone else's problem. But now you can't think like that. It is your problem. We need to address it. And I'm going to talk about sort of the definition of supply chain, why it's important, and then some best practices as well. So let me get started here. So first, I want to sort of talk about, everyone knows this, but it's worth sort of pointing it out. Over the last decade, we've had the digital revolution, digital transformation in the race to build apps, right? But life was pretty easy before this. If you're a software developer, you build your code, probably put it on some sort of build server, IT operations, take that code, deploy it to the infrastructure. But you did it within this perimeter, this very controlled environment. There weren't too many external influences. Now, if you fast forward to today, developers are working outside that perimeter. There's many external perimeters. And there's a massive ecosystem of tooling, open source libraries, third-party services that you can use to build applications across all industries. Some of these third parties you understand and accept the risk. Other ones are more anonymous and opaque. And that's why we're here to talk about the supply chain. There's a lot of complexity involved and a lot of unknown unknowns. So we need to sort of address this as a community and work out how we're going to solve this problem together. So let's look at the supply chain. Obviously, everyone's familiar with the physical supply chain. Take your typical manufacturing supply chain. It has many moving parts, right? It has your raw materials. It has different components. There's people involved. There's third-party suppliers. There's trucks. There's factories. All of that complexity goes to building products for end customers. And if any one of those components breaks or is disrupted, it affects the delivery time for those products to customers. I think that's well understood. If you look at a software supply chain, it's very similar, albeit digital, in that there's many moving parts. Your third parties have their own supply chain, so it's quite nested. And if anything breaks along the supply chain, there's a disruption in service to your end customers. I guess the only difference would be is that because it's digital, developers can write code and ship new features to production almost instantaneously. So within a matter of minutes, it could be in the hands of thousands, 10,000, 100,000 customers. So if there is a supply chain attack, it can be almost felt immediately throughout your third-party providers and your customers. Now, if you look a bit closely here, let's start with developers. So, developers are at the heart of this. They're using tooling like IDEs to write code, other developer toolings like CLIs. They obviously work on their desktop. All of those things could be compromised without them knowing it, of course, and they could distribute malicious code into the supply chain unknowingly. On the other hand, you could have some employees and developers that intentionally place malicious code into your supply chain. A disgruntled employee, let's say. There's a good example recently in the open source community. The author of a JavaScript open source library called Colors, which is pretty simple. It just allows you to highlight different colors in a command line, but has over 20 million downloads per week. So it's a very popular library. And the author was so fed up with huge corporations like Amazon, Microsoft, and many others using this tool without contributing back to open source. So what did he decide to do? He put some malicious code, an infinite loop basically in the code base, so that any applications that used the library crashed when they tried to run those particular versions. And it was actually used in the AWS CDK, which is obviously used by thousands of developers to interface with their cloud environments. So it caused massive disruption. He since deleted his GitHub account as well. So the point here is that it doesn't necessarily have to be sophisticated cyber attacks to affect your supply chain. It can come from within as well. So do think about that. Other influences for building modern applications may come from open source library usage. Modern software applications are composed of about 90% open source. Only 10% of the code is usually what developers write. The rest is sort of downloaded and constructed to sort of bootstrap the application, because it's so easy to do. Why would you reinvent the wheel? You'll just use open source, but obviously there's inherent risk there. And there's lots of vulnerabilities in the open source community. We've heard of ones recently like Log4j and the shelf for J as well, where over 50% of the applications on the internet were affected running Java. So do be cognizant of that. Containers as well. If you're using containers in your application, your developers may be downloading container images from untrusted sources and using base images where there's vulnerabilities inherent in the Linux kernels. So you need to be sort of checking for that stuff as well. If you go further, you'd be using a source control system from another third-party provider like GitHub or GitLab or any of the Git providers. And there's an element of trust there when using their products. You would probably also be using CI/CD platforms, and those platforms have other third-party plugins to help you run tests, security tests, test coverage type tools inside the pipeline. And those third parties have their own supply chain. So you can see it's sort of a complex web of components that make up those products that you deliver to customers. What I'm going to do now is actually talk about a few sort of supply chain attack vectors to help put that in perspective. So the first one is around open source, and that is, you may have heard this term, dependency confusion. This is the ability to trick developers to downloading the wrong open source packages that contain malicious code. For example, a researcher, Alex Burson, discovered that if you replace the public version of a library with the same name as the private version, so in the case of Apple, which was one of the companies that got hacked, as well as Microsoft and PayPal, actually about 30 other companies that got attacked with this mechanism. He discovered that if he hosted a library with the same name as the internal name, let's say Apple internal lib 1.0, and put that on a public domain, the NPM registry, then the package managers for JavaScript would actually download the public version, not the private one. And so when developers inside Microsoft and Apple compiled and packaged their code, unknowingly it downloaded these public packages with the malicious code. Now, luckily, Alex is a white hat hacker, an ethical hacker, and was not in it to exploit said companies, but it was interested in the bug bounties instead. I think he collected over $100,000 for his efforts there. And that's pretty cheap for someone like Microsoft to pay $100,000 to a developer to stop those sort of attacks. The other one was quite interesting as well. It's called typo squatting. This is where attackers intentionally have lots of different permutations of a name of a library in the hope that developers misspell it. Seems simple, but it's causing a lot of pain on the internet, where developers obviously, define their dependencies in their code and quickly move on to something else. And maybe they haven't really thought about or checking their work. But if they slightly misspell a library, then it may bring down some malicious code as well. Another one is around containers. Microsoft discovered that in Azure, a lot of their customers' Kubernetes clusters were compromised. And they found that attackers were running cryptocurrency jobs, mining jobs inside the clusters. This specifically affected customers running TensorFlow on Kubernetes. And the reason why attackers were able to get away with it for more than 6 months is because it sort of blended into the environment. The profile of the tasks running in the cluster were very similar to the machine learning jobs. So if you think about Bitcoin mining or crypto mining, it's high intensive on the CPU and memory, as is the machine learning job. So they just sort of blended into the environment and were undetected for more than 6 months. They got in through a flawed Kubernetes configuration where they were able to access an internal dashboard and actually launch code into that environment. We talked about developers sort of being the distribution of malware themselves. This one was sort of a nation state attack. North Korea, through some clever social engineering, worked with some security researchers on vulnerability research and got them to download a malicious Visual Studio project, which created a DLL on their machines and allowed North Korea to basically spy on these developers, what they were doing. If we move on to sort of what we call pipeline security, this one is quite interesting as well. CodeCov is a code coverage tool used by thousands of customers that does test coverage for your code before you deploy it to production. Here, the attackers got in through the backdoor, basically into a container, changed a single line of a batch script, and were able to export all of CodeCov's customers' environment information, environment variables, things like credentials, cloud server IPs, cloud services, etc., to a remote server, and then allowed them to sort of attack those end customers directly. And of course, we've all heard of the most famous supply chain attack, which is SolarWinds. Similar, this one is a bit more simple. Someone posted a username and password in a public domain. They got in through the build server and were able to slip in some malicious code as part of the compilation and packaging process before it was distributed to end customers. And the point really here is that the end game is not to attack those specific companies or vendors directly. It's to attack the customers in this sort of cascading attack. And we know from SolarWinds, where lots of US federal government agencies were compromised, it could be classed as a sort of nation state attack. So I hope that makes sense and puts it in perspective. If you want some more information, Sneak has come up with a cheat sheet around supply chain security, things like open source security, static compilation analysis, infrastructure as code security, something called an SBOM, which stands for software bill of materials, to basically define what components you have in your software, and for you to ask your third-party suppliers what components they have in their software as well. We have a more detailed white paper as well, which you can check out. But with that, I shall hand it over to Stephen.
Yeah, no, thank you, Lawrence, for providing us with that overview, right, and also for reinforcing the complexity of having different components nowadays that can increase that risk, and also reinforcing the importance of this of the supply chain security in nowadays. So yeah, next I would like to invite Stephen to please share with us a real scenario and talk about where the risks and concerns were identified and how a proper security strategy can help to mitigate those. Stephen?
Yes, thank you. Can we move to the next slide, please? Thank you. The next one. Yeah, so Ellie and Lawrence, thank you very much for the introduction and the Lawrence, the in detail analysis of supply chain attacks and some ideas. Before I go there, just a small description on Bank Jago. Bank Jago is a brand new, I would say brand new, a one-year-old fintech based in Jakarta, and one of the largest market cap literally in 1 year. So that also the financial arms for Gojek and all the other entities. So we kind of stand out in terms of a place to attack. You know, in Bahasa we say something. We say, "Di mana ada gula, ada semut." Where there's sugar, there is an ant. So that's where we are. So we have a lot of people are focusing on us, and based on that, I mean, the three particular attack we see quite often in that area is obviously the watering hole, which I think Lawrence covered a lot, where people are, I mean, the hackers are trying to infiltrate the on the very common commercial platforms. So people consume the platform in essence, saliently embedding malware. And then the other two major thing is the go where the money is, right? So they try to embed malware into data store, right? I mean, we are API economy, so all the data stores are very, very critical. And sometimes we have partners, and I said we means may not. Be very careful how I say that, but again, I'm not sure the endpoint security, God knows in what kind of state it is. But in some chances, right? I mean, they can get a malware to the malformed endpoint, and the next thing you know, all the crown jewels could be exfiltrated, and then we do see that on the remediation or before remediation sometimes. And then the last thing, obviously, Lawrence discussed a lot. It literally compromising the supply chain or the software pipeline development of a particular software vendor, in this particular case with SolarWinds. But something major happened for the first time in America last week. Take that back, 2 days ago. For the first time, the federal government has allowed a company to sue SolarWinds based on that breach, which has never happened before because it's difficult to pinpoint vulnerabilities. Could be stated to a nation state attacks, which becomes another cyber crime, becomes cyber warfare, so whatever it is. But as we speak right now today, for the first time, the federal government has allowed for a lawsuit on the SolarWinds attack, which is actually compromise a supply chain breach. And next slide, please. Sorry. So and the oddest thing is that the team asked me to come up with 3 things, major thing on a supply chain security. And these 3 things we see, the first 2 things actually came from last 2 weeks. Just like last week. So the first one is the Lenovo attacks, where we see a lot of malware embedded on the manufacturing side. So literally people are using a malware, you have DLP, you have what kind of tools you have. On the kernel level, things could be exfiltrated. I say could be, right? So again, what was the features? What was the security on the supply chain development? What was the status of DevSecOps on the manufacturing side, or on the consumer side, or even on the supplier side, really? So that's the first one. The second thing is that I think Lawrence alluded to that too, because the overall in GitHub lab, where people have embedded in an authenticated token, which is illegal. I mean, illegal authenticated token coming across as a very legitimate clean token, we're able to embed into Heroku's and Travis CIs, and end of the day, most developers use them for day-to-day work. The last thing is Log4Shell. That's during the Christmas time. So obviously, yeah, all these major 3 things actually is not something that happens before. It's literally last week. So that shows the emerging threats for security people coming from the supply chain efficiencies, really. Next one, please. Coming back to SolarWinds, and before this particular gig, I was working in the government industry. So we actually saw that, as Lawrence said, right? We actually saw how someone can manipulate a DLL into an original certificate. And when you have an authenticated certificate, you never question that. You should, but you don't. I mean, there's a lot of reasons behind that, right? But again, this is exactly how SolarWinds happened. The other thing actually happened is that for them to change the certificate, and they actually bypassed Cisco, Duo actually is owned by Cisco right now, authentication, access control, 2FAs actually. So there you are. I mean, the more layers we put in, the more layers is becoming more and more brutal. Can we go to the next one, please? This is actual certificate when I was in the government, and I saw that actually a Microsoft certificate that came through SolarWinds. So the DLL get compromised, it goes to update services, and SolarWinds sends to millions and millions of customers for network monitoring, including security monitoring. Imagine that. Next one, please. So, I mean, why do we see that? I mean, why do we see a lot of breaches, a lot of potential breaches and breaches in the supply chain, literally? Okay, so obviously the first thing is the open source. I mean, most of us are moving more and more into shifting lab, DevSecOps, and then we're literally trying to build software like a fintech software, literally very fast. Obviously, we import libraries coming from open sources, but the problem is that open sources are compromised, as Lawrence has brought up earlier, right? And then also is that poisoning of open source packages is widely used. It's been used before too. It's just the implication, ramifications never been felt before. But since we are rapidly developing software, we are seeing this, the negative ramifications very fast. And then the CI/CD tools, really, I mean, Lawrence showed a picture of all those vendors there. I mean, looks like a beautiful collage of pictures. How sure are we whether all those binary authorizations and all the softwares are well tested? I mean, you don't have to go to nation state, just simple software development processes and governance. Is it there? We don't even know, right? And manipulating the build process, obviously, is a typical SolarWinds. I mean, once you are into supply chain, it's very difficult to detect that. So it's the same challenges we have, because what we do, we used to have a lack of visibility. We were starting a company and we're doing a lot of things manually, some are legacy codes. And so we didn't have any resources visibility. And then that's the second thing. When you build a company, you don't build a company based on mitigating all the security scenarios, because we're not in a business of security, we're a business of in a banking business. So we do a lot of trade-offs, compromise, but trade-offs, for better business outcomes. So obviously that the engineering teams, in some cases before did not have the right resources and the tools. And then the supply chain attacks, right, is very, very difficult. And once the software is embedded, once the software comes in nice polished packages, right, first, the human nature is that it will never doubt it. Second thing is that, again, coming back to the first 1 and 2, the lack of resources, the lack of testing tools, and things go through. So that has been our challenges too. So next slide, please. So so what do we do? What do we do really? What are we doing things differently right now, right? Obviously, we really has embraced DevSecOps. We hired people who have done DevSecOps, and we also train developers into the DevSecOps mindset, really. And to be very honest with you, when we were interviewing people and for developers, sometimes they have a hard time differentiating between 2 tokens, let's say JWT tokens versus OAuth tokens. So see, this is very difficult when you're not really in tune to understanding the fundamentals of security coding. It's very, very difficult to do things. You can do DevSecOps and also able to have secure coding practices. So again, that's one thing. Second thing is that they count more and more on instrumentation, IDEs, and all those things. So obviously, so we check a lot of IDEs these days to make sure the licenses are good. And then other areas, making sure the pull requests, PR requests are very valid, well segmented. Each session is tested. The third thing is that automated fixing. The other thing I want to say is that the more automations we do, the less human touch we do, there's a less prone for us to make errors. So again, automating fixing fixtures is quite good. And then to integrating our tools automatically. And then the last thing is that testing our runtime environment. I mean, we do all the testing in DevSecOps model, but sometimes a lot of people make a mistake on the runtime, right? Because it's very dynamic there. Next one, please. I think that's the last one, I think.
Yeah, Stephen, can I just add a comment on the last point there? On the runtime piece? When I talk about your SDLC or your software development lifecycle, I also include production, right?
Yes.
Because things can change from during development to when you've actually deployed them. So you need to detect if there's any drift, right?
Absolutely.
And then keep patching accordingly.
Yeah, precisely, yes. It's an end-to-end thing, to be fair. I mean, yeah.
For sure.
Yeah.
Yeah, very, very interesting. Like, thank you for sharing that, for sharing like the risk, the use cases, even the root causes and the challenges that you have seen, Stephen. Thank you both. So I think we can move on to the discussion part. I just wanted to let everyone know that, again, please share with us if what the speakers here are sharing is something that you see as well in the industry, in your companies. If you have any question, please add those, because we will have time for that at the end as well. So right, moving to the panel discussion, as I said, so according to the NISA threat landscape report from last year, software supply chain attacks are at number 9 of the most common cyber attack vectors. So as the speaker were saying, because of the complexity and how dynamic the environments and the SDLC process is now. And at the same time, the case for open source software is compelling and has now become a standard part of the application development process. So before we talk about the technical part or some technical controls and best practices for this type of attacks, let's talk a little bit more about some of the cultural changes that are required in organization. And Stephen already talked about in the last slide about even the hiring process and the skill sets for the DevSecOps teams. So Stephen, how do you bring the security teams in the early stages of the development without getting in the developer's way? How do they think about security in the early stages of that process?
Good question, Ali. I mean, yeah, we force them to test. I'm just joking. It doesn't work that way. Right? I mean, developers are human. I mean, no one likes to test very much. I mean, once you write a code, you like to pass it through. No. Yeah. I mean, what we do is precisely, actually, it's quite simple. We try to get the security team involved on the planning stage instead of on the middle or the backward stage. Like we have security architects actually get into the code level, understanding business process level. And then we also set the proper tools to be in place in terms of, for example, people actually importing libraries to check. But end of the day, again, security people are security people, developers are developers people, but getting the security people up front, getting them involved makes a humongous difference, regardless of technology, the governance or the process. You know, the second thing also is that we have learned not to say no for anything. We have to say yes and think about it. So you don't come across like Mr. No. It has given a bad culture for developers to deal with security because we come across like very negative or prolonging things. So again, able to work with them, listen to them, honestly, and then able to work with them from the very beginning, from the business case level. So that has made a big difference for us, honestly.
Yeah, that is important. And as you said, also considering the automation, right? That is something that we always share with our customers. Like those controls that you can automate are going to help you to avoid the manual and the human errors. So that is important. Yeah, thank you for that. And I know that like Laurence, I'm sure you also have some experience in that sense of the cultural shift that is required since the technology that was used before, as you said, things were a bit more like simple. So 5 or 7 years ago is not the same that the complexity that we have today. So what techniques do you use to foster the collaboration between as Stevens was saying, the developers who will continue to be developers and the security team to work together and in a right way?
Yeah, before I jump into that one, I just want to say, I think the audience is quite shy today. I almost want to say something controversial in order to get some reaction. So maybe I will later. But yeah, do make it interactive, folks. Let's have a discussion, right? But to go back to your question, Ali, I think to me, it's less about the tooling. Yes, obviously technology helps and it's definitely improved in the last sort of decade, but I think it's more about the collaboration that's happening between dev and security teams, right? It's pretty simple. It's common, I think, for these days for security teams to get involved in the design phase of a software project, which seemed ridiculous sort of 5 years ago, but because there are going to be some initial security requirements, but I think most importantly, what does that ongoing collaboration look like during development? So things change, obviously, in an agile software project, change direction or features get dropped, new features get added, which may impact security. So having your security team sort of I would say, part of the extended development team throughout the whole process, not just sort of at checkpoints, every 3 months or at the end of the project. Have them embedded in the team, I think is the way it should be done. Obviously, we're talking about DevSecOps here, but the other way is have engineers who try and put the security hat on. I know obviously engineers aren't security experts, but there's a lot of engineers who have an interest in security. And you may have heard of this term security champions program. I don't know if you do it in your organization, Stephen, but maybe you can talk about that later. But it's a good way of sort of bridging the gap between developers and security, because what it allows is engineers who obviously know the software domain, know the engineering practices, have an interest in security and sort of skill themselves up in security. They can have empathy for engineers and represent the engineers, but also now start to have empathy for the security team. And it's a good sort of career option for engineers who want to sort of go down that track. They can enable other engineers on security practice, and that's the way you're going to sort of scale this kind of culture across the organization. I don't know if I answered the question. I took the more sort of process side than tooling side. Yes, tools like Sneak help because they embed in different places in the SDLC and are sort of frictionless, don't get in the way of developers building fast. But I think it's going to come down to a combination of good tooling and good collaboration, good culture.
Yeah, no, absolutely. And actually, it's very related to what I wanted to ask to Stephen next, right? Because we keep sharing best practices, but the reality is that executing those best practices in a real organization sometimes is not as easy as it sounds, right? So I wanted to check with you, Stephen, like, how do you see that like, do you have that security champions program, or do you have like at AWS, we have the technical field community for maybe those, as Lawrence was sharing, those that are not security people per se, but have an interest and help to bring those different teams together. Do you have something similar in Jago Bank, and how do you see, if you have that, how do you see that can accelerate the adoption of the DevSecOps?
Yeah, no, that's a very good question. Really, very good question. Because I'm speaking from a pain experience perspective, really. So now we don't have a security champion per se, but we have principal engineers who are very security focused, right? And I'm open to say that because we do have a sister bank, and none of them are security people, and they have the best security certification, whatever you want to call it, in terms of the bank itself, the program wise, because they've been doing security by common sense without thinking about security. So it goes both ways. Why I'm saying that is that, so innately they have a security mind to do things secure. What was lacking? I want to come back to the tools, really. I mean, I know I want to come back to the tools, really. So I'll be very open with you. We use Sneak, right? I mean, I'm happy to say that because we lost people on the development side, the security side, because they said, yeah, QA tools are not automated. Like, so that's a big pain point for us. So now we have a lot of automated tools. We have security built in on IDEs, on our static dynamic testings. We have tools. So it's making developers enjoy their work and enjoy seeing how the hard labor is actually done. It's also making us actually be very comfortable trusting developers, because first of all, less hand goes into it. Second thing is automated, and we get reports. Literally, I get weekly reports. Could be 3 times a week reports. We found this, we found this, we found that. This is a remediation. It's helping us a lot. So I'm taking a little technology perspective on the people perspective, how the technology tools actually helping people to work better. Really.
Yeah.
Hey, Ali, sorry, just jumping in here. There's a question in the Q&A which is related to what Stephen was talking about. If you don't mind me jumping in and answering now.
Sure, please go ahead.
So I'll read the question out for folks. When shifting left, how far do you go? Can developers shift right and be responsible for infrastructure related security also? So I think this is a good one, whoever asked it. So I would say the IDE where you write code is the farthest you can move security controls, so that developers can get real-time feedback before they actually check in any code into the source control repository, right? So they get a chance to sort of remove critical high vulnerabilities in their code or their open source or their containers or whatever they're using before it sort of gets distributed to other team members, right? And I like the other part of this question, which is, can developers shift right? I often talk about this as developers are being empowered to own more of the infrastructure. If you think about infrastructure as code, cloud configurations are being codified into things like Terraform, CloudFormation, etc. And who owns that? Well, who's the best person to own that? Developers, because often or not, those assets or those files are checked into the source code repository alongside the code, right? So they're in there anyway, updating the code and adding features. Why not manage the infrastructure requirements that's specific to those applications as well? But in doing that, obviously there's a big responsibility there now, because they have to not only maintain the sort of functional aspects of those configurations, make sure their applications work, they also need to own the security aspects. And a lot of developers aren't equipped to do that. So I'm going to contradict myself. This is definitely where tooling helps to make sure that developers can go fast, but also stay safe by using tools to actually scan the output that they create. Hope that makes sense.
Yeah, can I add to Lauren's comments really? So shifting to the right, obviously, mostly operations, right? But this is what we do in Bank Jago. So on the shifting to the left side, we get all those alerts from Sneak, right? So when we do correlations, what people are observing, right, on the runtimes and all that, we correlate. You say, did we mitigate that? What's the KPI? So again, it goes back and forth. It's a correlation between right and left. It's just not one way going to the right, one way to the left. So security people actually, I have SecTech actually use Sneak's alerts to make sure that they actually mitigate it. They're not seeing this. So again, it's a digital river, digital flow back and forth, really, you know. So it does. So answer is yes. Long way to say that.
Yeah, thank you for that. And yeah, again, it's as you're saying, a combination of both, right, culture and tools. So we are getting some questions. We will cover that in a minute as part of the Q&A. But just before we move to that portion, right, I wanted to end the panel discussion with a final takeaway from each of you. I don't know, Lawrence, do you wanna start that? Like, what do you want to share with the attendees today as a takeaway?
Yeah, for sure. I mean, software supply chain security is a bit of a beast, right? There's lots of moving parts and it's complex and opaque. So I think my advice would be start small, maybe look at your application dependencies as a first thing. You can't do everything at once, right? But I think you're going to get the biggest bang for buck working with developers on, say, open source libraries. Definitely use an SCA tool, software composition analysis tool, that's going to scan your direct dependencies in your applications, but also, probably more importantly, indirect, or what we call transient dependencies. If you look at the log for shell vulnerability that Stephen talked about last December, over 60% of occurrences of that vulnerability were in indirect dependencies, meaning developers may or may not know they even imported that particular library in the first place, or they're in sort of third-party applications that you use. So a lot of people were caught sort of unawares because they didn't even know they had these issues, or they had Log4j even in their systems. And I think that's the biggest black hole that we can try and solve together, is what, and it goes back to my comment around the software bill of materials. What is actually running in my applications in production? If you can sort of solve that, you'll go a long way to sort of helping to stop some of these supply chain attacks.
Yeah, just to add to Lawrence, really, I mean, from a practitioner point of view, and we always have been focused so much on the internal software development. We took everything from the outside as a gospel, everything is good. now obviously we have learned a lot. That's not true. So again, don't take any chances. We ask a lot of questions, verify independent software products, and then making sure the library we import actually is kosher. So again, we are thinking things differently, really think differently. So again, this is a good topic, guys. Really, it's a good topic and critical topic to discuss.
Yeah, Andreas actually in the chat raised some good points. So there are several industry frameworks that you can look at out there. NIST, ISO that he mentions. They each have sort of developed white papers or best practices around supply chain. I mean, this topic is fairly new, right? I mean, it's been around for a while, but giving it a name, the supply chain security, is kind of a new concept. So a lot of the foundations, CNCF, Open Source Security Foundation, are developing new guidelines around it. So a lot is happening in this space. Thanks for the mention, Andreas.
Yeah, and on top of that, like if we move to those questions, right? On top of those standards, we also have a question from Trangbu. So the question is about any best practice or checklist. Maybe those can even come from those standards or organizations, right? Any best practice or checklist suggested to exercise security by design? Who wants to take this one? I see both of you are on mute. Stephen.
No, they are there. I mean, at least from the engineering by design, there's so many frameworks up there, you know, like I forgot. I mean, I haven't forgot. You just put me on the spot, but I can send this particular person if they're interested, really. You know, this again, NIST has a lot. I mean, guidance there, and Department of Defense has a lot too on that area on supply chain security. And then also on the CCM certification, it shows how supply chain should be checked every single level. I can send more data if they can ask me. I mean, they can email me, really. But Lawrence is a practitioner, so let me ask him. I mean, in this case, Lawrence may have a better answer.
Yeah, the one I point to is you'd be aware the US federal government had the cybersecurity order last year, and there's a lot came out of that. One of the pieces was the software bill of materials as from the NTIA. So that would be definitely one to check out. The SBOM is going to sort of help document in a standard way what's running in your applications, but more importantly, in the context of supply chain, what's running in your third-party suppliers or services that you use. And you can ask for that via an API and get this common format back. So that's a great place to start, right? Sort of baselining or have a foundational knowledge of what's actually running in your systems.
Yeah, just not taught me that the CSA, the Security Cloud Security Alliance, have a good matrix regarding software development across many certifications and mandates and all that. Just go to their website; they have it. They're very good ones, actually. You know.
Yeah, thank you for that. We also have a question in the chat. So the question is, in this case, thinking more about internal threats. So is there any suggestion on how to detect whether the developer themselves injected the malicious code or illegal backdoor into their application? Any?
I can answer quickly, and I think Lawrence may have seen more because yeah, no, obviously, right? I mean, the segregation of duty, the code signing, and then the handovers all should be really documented and well monitored, really. For example, what we do is that the developers have no access to the to other people in the supply chain, right? So and every single code has been checked with stage by stage. So we want to see the integrity of the code and changes, who made the changes, and things of that nature, right? Then the last things that before release is that we test for those kind of scenarios, ASH testing, so integration testing. So you find this out. I mean, one thing people don't realize is the insider threat is the most prevalent than anything else, really. I'd be very surprised about that. Go ahead.
Yeah, sometimes Yeah, sometimes by mistake, right? And sometimes maliciously. Lawrence, do you see any difference or anything to add to what Stephen shared about how to protect in those cases for insider threat?
Yeah, all of the things that Stephen mentioned, obviously good code reviews process to quality check the code along the way. There are good sort of QA or quality code analysis tools as well to use with your security testing. But I think around the backdoor one is a little easier to detect because if you think about it, in order to have a backdoor, you need to sort of spot or allow a weakness or a vulnerability somewhere in your code. So if you're using a SAST tool anyway, static software testing tool, it's probably going to pick up the evidence of these backdoors because, for example, if you're not sanitizing input variables for a website, right, and passing variables straight through the database, it's open to a SQL injection attack, right? So your SAST tool should pick that up, or cross-site scripting, or so it may be hard to actually put in a backdoor if you've got a proper static analysis tool or constantly scanning the code, right, in conjunction with those sort of other checks that Stephen mentioned, I think.
Yeah, that is right. And I wanted to, in relation to that, right, I understand that we are trying to balance, so moving from that traditional approach of millions of approvals before you can move the code to the next environment or any other change, right? And at the same time, maintain those key reviews and tests. But how do you balance those? You know, like, is there any tip that you want to share with the attendees today on how to move fast and at the same time maintain the minimum level of control or test?
Yeah, for sure. I can answer that one first. This one, I think you want to invest in tools that do a lot of the heavy lifting for developers, right? So if developers have to process a huge list of vulnerabilities and security concerns, they're never going to do it. Let's face it. I was a developer and I never got to those things because I had higher priority things to work on for the business, which is delivering features, right? But if a lot of the hard work is done for you, sort of removing that cognitive load, for example, what Snyk does pretty well is issue a pull request if there's a vulnerability in your applications, and you just basically have to accept or reject it, right? And we do a pretty good job of making sure that there's not going to be a breaking change within the context of open source. You know, if there's a vulnerability in open source library somewhere deep in the dependency tree, we're not going to just upgrade you to the latest version of the library because that would probably cause breaking changes because it won't be compatible with other libraries or your code that you're using. Instead, what we'll do is figure out when is the next version that is safe. In other words, when was that vulnerability patched, and use that version to upgrade and issue a pull request, and developers can accept or reject that and move on with their next task. So I like to say that Snyk almost becomes invisible in that sense. That's not getting in their way.
Yeah, the good points. Anything else that you want to add, Stephen, to that answer?
No, we use that tool, so I can attest to that. Let me, I don't know what else to say besides that.
You can just agree with me, Stephen.
Yes, yes, I do. I've been very agnostic here, but it's true.
Awesome. Yeah, thank you so much. So that's just about all the time that we have for today. I wanted to thank you all for joining this session, and especially our panelists, because they answer all the questions, not only those coming from me, but also those coming from the attendees. So thank you so much. We have seen in this session how the complexity and how interconnected the environments and the different blocks are, and how security for each of those components is very important for the overall security of the delivery model. So thank you so much for sharing again your insights about that. I learned a lot about today's topic, and I hope everyone did as well. So again, just wanted to thank everyone and to we hope to see you in the next event.